How does this digitizer work, Brant?
Well, the digitizer has 5 axes of movement, and what we're trying to do at all times is tell the computer the exact location of the tip of this pen at any one time. So to do that, it has to know where it is in the Y direction, also in the X direction, the length of the car, and in the Z direction, the height of the car. The other 2 degrees of freedom are the theta direction, which is just an arbitrary name that we call it. It's to allow us to do sloping surfaces, as well as the omega direction, which allows us to rotate the model to do planes of the car in this direction. To do a digitizing step, what we do is set the pen on the model at a place where we would like to begin. Then we start the computer and follow the model in the direction that we're concerned about. All the time, the computer is reading the position of the tip of the pen through the voltages of the potentiometers at any time. We do that, the computer stops sampling, and then we're able to look at the data that has been gathered by the computer throughout this step, and then plot a picture of the car, a 2-dimensional picture of the car in the longitudinal direction, either quarter scale like the model, or we can scale it up 4 times to bring it to the actual size of the car.
This is a wind tunnel model that we've been working with for the last couple months or so. And the purpose of this model is to measure the air pressure on the outside of the model all over the body. So to do this, we have little pressure taps all over the place, and these are just openings in the model that are connected to little rubber tubes, and these in turn are connected to the computer where we measure the pressures. Now, the purpose of measuring all of these pressures is so that we can find out where we can put inlet ducts for engine cooling. We have an engine that sits right back in here that needs to be cooled by air. So if we know the air pressure on the outside of the model, we can decide where to put inlet ducts to let air in at a high pressure region, and we know where to put outlet ducts at a low pressure region. We did a lot of work, and I did a lot of analysis on this, and after trying a few different things, we found the only really place we can bring air in is right up here in the front of the car, right in front of the windshield. This corresponds to a lot of the inlet ducts you see in passenger cars for occupant heating. So what we're planning on doing is bringing air in here, ducting it vertically downwards, and letting it out back in here. We have a high pressure region here that pushes the air in. We have a low pressure down in here that pulls the air out. But there's only one problem with this. The engine's back in here. So what we've had to do is we're mounting a small heat exchanger, and we're pumping the engine oil all the way forward to this little heat exchanger, running it around the heat exchanger and then pumping it all the way back. And this way we can take part of the cooling load of the engine. We can't take all of the cooling load, unfortunately, because we're limited as to how much heat we can dissipate with a cooler like that. So what we've also done is we're putting an inlet grill right in here on both sides of the car, and we're forcing the air to come in this with a fan. And we have a fan mounted inside in front of the engine. It pulls the air in on either side of the car, past the engine, and then we get rid of it back in here again. We have another outlet grill. And that fan is driven electrically and from the battery. So we have a two-fold system. We have an oil cooler up front, which partially cools the engine, and we also have a fan mounted in the back to force the air over the engine. One of the advantages of having an oil cooler up front here is that we have a source of heat at the front of the car to warm up the occupant compartment. We're going to be doing some of the testing with this car in the winter, and we want to be able to see out of the car, and we want to be able to stay moderately warm, hopefully. And so we're planning on using some of this excess heat to warm up the passenger compartment also.
Okay, I'm talking to Dave Hunchak here. Can you tell me, Dave, what this is in the background and how you've constructed it?
Well, this is what we call a body buck. It's in the process of being constructed now. And we got these templates from digitizing this model, which is what Brant talked to you before about. This part here is essentially the bottom of the car. So from the bumper line to the bottom of the car, it's a model of that in full scale. And what we're going to do with this is cover it with plywood and strip wood and then body putty it and give it the final finish that'll be exactly the same as what the car will be. And then from this body buck, we'll take a mold off it with fiberglass, which would be like a big bathtub, a negative image of this. And then inside that, we'll produce the actual car bodies out of fiberglass, a composite material. So it's essentially like building a boat the same way they do that, except we're applying it to building a car.
I do excellent work. That's good. You realize that if you don't start earning up, you'll be down the road just